Okay, here is another wonderful Jason Ladanye video that I wanted to look at. It's a great one because it uses two powerful principles. So he has two packets of 15 cards, and then spectators are free to cut any number of cards off of each. Now he's going to set the king face up on one and the queen face down. Now instead of stacking the piles back where they came from, he switches them. And this is called the free cut principle, and then he randomly stacks those, okay? Now this packet can be freely cut as many times as you like, and it won't upset anything that he hopes to accomplish. Now what he's going to do is he's going to deal the cards left, right, and keep the pile with the up-facing king of hearts, okay? Now from that point, it's using something called the 2 to the n minus 1 principle. Now for the free cut and this 2 to the n minus 1 principle, I'll have videos linked in the description below that will teach you about these ideas because they're very useful in many, many card effects. So you just discard the pile that did not have the up-facing king. You deal out the cards again, keeping the pile with the king in it. There it is. I think he has a couple more dealings. Okay, get rid of the pile without the king. And then one final dealing, I believe. There we go. And as you might imagine, the queen is guaranteed to be there with the king. Now, because of the free cut principle, since he started with 15 down-facing cards in each pile, and then he set the king on one pile and then the queen face down on the other, despite the fact that you cut off those random packets and then switched how you stack them, the king and queen are guaranteed to have exactly 15 cards between them. Now 15 is a very important number, and that brings us to the 2 to the n minus 1 principle. Okay, so let's talk about this here. Okay, so first off, 2 to the n minus 1, that's just referring to a power of 2 minus 1. So for example, when n is 1, it's 2 to the first minus 1, which is just 1. N is 2, you get 2 squared minus 1, which is 3, and so forth, all the way up to 2 to the fourth, for this presentation, minus 1 is 15. Okay? So the numbers of importance in this presentation are 15, 7, 3, and 1. Now, relative to the LR deal, these are all related. Because if you begin with two cards, let's say the king and queen, and there's 2 to the n minus 1 cards between them, after just one left-right dealing into two piles, the king and queen will end up in the same pile. Now, one thing that Jason didn't do, which you could do, in fact, maybe I'll just quickly illustrate it here. So let me just step through this because there's more that you can do as a convincer than Jason did. Now, he maybe was trying to keep the video from being too long, which is fine. So you start with 15 cards in each. You can cut any numbers of cards. And if you remember, he had a king face up and then a queen face down. But maybe we'll leave the queen face up so that we can see what we're doing. If you take these and then you switch where they go, that's where we're using the free cut principle. And then if you randomly stack these, it's guaranteed to be the case that there's exactly 15 cards between the king and the queen going around corners. What does that mean? The king is here. So if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There will be 15 cards to kind of wrap around to the queen, and of course 15 cards in here. Okay? Now, he did show that you can actually randomly cut this. Perhaps more convincing is to use the Chardelier shuffle, actually. So I can add a link in the description below to the Chardelier shuffle because it's just so messy. And then you could follow that up with a random cut by the spectator. That would probably be a good idea. And then if you just deal them out, and we're going to keep the pile with the king in it. Now, normally the queen is face down, right? I mean, that's all part of the mystery. The queen is face down, but if you can see, she has landed in the same pile as the king, right? Now the claim is by this 2 to the n minus 1 principle, there will now be 7 cards between them going around corners. So 1, 2, 3, 4, 5, 6, 7, you get to the king, and then there's 7 cards here, okay? So that's also a power of 2 minus 1. Now what he didn't do, which you could do, is you can actually randomly cut at each stage, okay? So between the dealings, you can perform as many Charlier shuffles, which are highly convincing because they're so messy, or just have the spectator randomly cut it like that, and then continue on. We're looking for the up-facing king in the actual performance because the queen would have been face down. Okay, so there's the king, and as we saw, the queen's right there. But look at how many cards are between them. 1, 2, 3, that's a power of 2 minus 1. And then going around corners, we have 3 as well. Okay, and this can even be cut randomly or Charlier shuffled. Okay, so if the spectator get in there and randomly cut it, that's great. And then just do a left right again, keeping your eye on the king. That's really what you're watching. Okay, and then if you notice, there's only 1 card between them going around corners, right? So you could even have the spectator, remember this would be face down normally, right? Spectator can cut as many of these as they like, okay? And then go into the final dealing and then reveal that the king has found her queen. Okay, very good. Though this is a simple effect, it actually is drawing on some very powerful mathematical principles in card magic. So thank you for watching, and take a look at the videos linked in the description below, as well as watch Jason's original video. And beyond that, I also encourage you to take a look at other videos on the Absolute Math Magic channel.